Welcome to video 7 of the Maintaining a Balance series. In this video here, we're going to look at specifically at oxygen and carbon dioxide and the role it plays in our blood. We've got 3 syllabus dot points, 2 of which are skills and practical-based and research-based components. And the first one is we're going to again revisit the need of our bodies for oxygen, and also why it's really important that we remove carbon dioxide, which is the waste product from cellular respiration. We know that cellular respiration is responsible for producing the energy that our body requires to complete all of the metabolic reactions. Oxygen is a reactant in that cellular respiration reaction. So it allows for glucose to be oxidized to produce ATP, which is the form in which our body uses energy. Carbon dioxide, however, is produced as a waste product of chemical respiration, and it's really important that the carbon dioxide is removed so we prevent a change in the pH of the blood. Again, we know that carbon dioxide is a waste product, and when carbon dioxide dissolves in water, it can form carbonic acid, and carbonic acid is toxic in cells. Carbon dioxide dissolves in the water, which is found in our body's plasma, and we know that plasma is 90% water. So there is a high chance, if that carbon dioxide level is high in our body, that it might stay in there to form carbonic acid, which would be um, quite harmful to our body. Exhaling, which we know is the process by which our body removes carbon dioxide quickly from our body, avoids that carbon dioxide interfering with any of the other chemical activities our cells need to undertake. If the pH of our blood is lowered, so as it becomes more acidic, it affects our homeostatic balance. We know that when our homeostasis is not achieved, that our enzymes don't function as optimally, and thereby reducing our metabolic efficiency. The practical which we're going to complete in class is to measure the change in carbon dioxide level in water and how that affects the pH. This flow diagram here represents the practical component in which we're going to be using technology in the form of a data logger to track that pH. And a good thing about a data logger is it produces the curve for us. We are going to be dissolving carbon dioxide into some water by exhaling. So we know that carbon dioxide is found in the air that we exhale. The next component of our dot points for today's video is to investigate some of the technologies used to measure our oxygen and carbon dioxide levels in our blood. So we're going to be referring to these two technologies. We've got arterial blood gas analysis, sometimes called ABG analysis, and we're also going to be comparing that with the pulse oximeter. Arterial blood gas analysis allows doctors and medical professionals to measure the concentration of oxygen and carbon dioxide from a blood sample, but it only allows that to be done at an exact point in time. It's quite an invasive procedure, so the blood has to be extracted from the body in the form of a needle. It's an electrochemical procedure, so the sensor reads the chemical composition of the blood and then produces an electrical signal, which prints out a set of results, as we can kind of see here from our technology. So it prints out an analysis of that blood that's been removed from the body via a needle. What's really good about the ABG analysis is that it can measure oxygen, and it can measure the partial pressure of oxygen and oxygen saturation. Oxygen saturation is how much oxygen is bound to the hemoglobin molecules in our red blood cells. Also measures the partial pressure of carbon dioxide. It measures the pH of our blood, and that is able to link to the amount of dissolved carbon dioxide in the blood. And then it also can measure the bicarbonate ions, and those bicarbonate ions are important in our blood as they prevent acidity, and their levels in the body are a good indication of how well the kidneys are functioning. If we compare that to the pulse oximeter is a non-invasive procedure and it measures indirectly on a continuous basis. So you might know from, being in hospital yourself or watching lots of movies, the placement of a device onto the finger, and this is in fact measuring the amount of oxygen in the blood. It's an optical procedure, which means it uses a sensor to translate light into an electrical signal. Um, it does that by seeing how much light is absorbed, and that the amount of light that is absorbed determines how much oxygenation is inside the blood and how much is attached to that hemoglobin. But the good thing about the pulse oximeter is it measures the pulse as well as the oxygen levels in your blood. A few keywords to look at for your glossaries to make sure you've got respiration. Make sure you understand carbonic acid and how that relates to changes in the body's pH, but also familiarize yourself with partial pressure and oxygen saturation. One of your tasks for this lesson is to create a comparative table to look at both the pulse oximeter and the ABG analysis and make sure you understand how and when they're most appropriate for use. Obviously, this is a much more invasive procedure and will take a bit more time to get the readings, but it does measure a lot more of the chemical analysis of the body. But the pulse oximeter is non-invasive, it's quick. It can be done almost immediately as a person arrives at hospital. Um, it's non-invasive, and I guess the good thing is that it's continuous, so we can measure the oxygen levels over time. Thank you for watching video 7. Make sure you tune in for video 8.